right, so in number 5, we have a graphing problem with the circle. And we haven't actually done one where you had to graph the circle yourself, I think. But it shouldn't be too tough to do it. So in the problem, they tell you the center point is 3, -2. So 3 down 2. Oop. Oh, shouldn't be a problem if you don't have this program. There's the center point. 3, -2. Actually, I'm going to move it over. I'll do it over here. The radius is, what is it? It's 10. So if I go up 10 units, the x has changed by 10. Or sorry, the y has changed by 10. So -2 plus 10, I'll be at 8. So this point right here is 3, 8. If I go down 10 units, the y becomes -12. So this point down here would be 3, -12. If I go 10 units this way, I'll end up at 13 for the x value, and then the y stays the same. And if I go 10 units the other way, then the x is decreased by 10, so I'd be at -7, -2. So I'll connect these guys and do my best to make a circle out of it. Whoop, that didn't show up very good. There. Okay, so there's my circle. And let's see, graph the line x equals 5. So remember, lines that are of the form x equals 5, they pass through all the points where the x coordinate is 5, like 5, 0, 5, 1, 5, 2, ... right? So 5, 0 is right here, 5, 1 is right here, 5, 2 is right there. So x equals 5 is the vertical line that goes right up and down there. So it's this line right here. And it goes down this way. So this line is x equals 5, vertical line. Find the coordinates where the line and the circle intersect. So that's going to be right here and right there. I do know one thing about them already. I know that since they're on the line x equals 5, the x coordinate has to be 5. Okay, so we've got 5, comma something. And down here we've got 5, comma something else. So at the very least, we know the 5s. So I'm going to put a 5 here and 5 there. Okay, let's see. Well, pretty much anytime we have a problem, we make slope triangles on a graph. So let's see, if I go straight up to this point, I can come down here and across. So there's one slope triangle, and then I've got this other long, thin slope triangle right here. Now, you can figure out one thing in particular about this slope triangle. You can figure out that across, I'm going from x equals 3 to x equals 5, so this is 2 units across. And we already know the radius is 10. That was given in the problem. So I'm going to redraw these triangles right here to exaggerate them a little bit. This is 2. This is 10. This is 10. I know that this point is 3, -2. And the goal is to figure out where these points are. Well, I can use Pythag to figure out how long this side and this side are, so I'll call those b. So if I do Pythag, I got 2 squared plus b squared equals 10 squared. So b squared will be 100 minus 4, which is 96, so b will be √96. Okay, so this is √96, and this is √96. And I'll put it here too, √96, √96. So when you think about where these points are going to be located, like if I'm just looking at this one first, well, I go over 2. So to the right 2 means that the x increases by 2. So that's 5. And then I go up root 96 from y equals -2. So if I'm going up root 96 here, I take my y value and I increase it by root 96. So the y value is -2, and then I'd increase it by root 96. So this would be -2 plus root 96. If you turn that into a decimal, so I'll write it here, -2 plus root 96. If you decided to use decimals instead, then that would be 7.798. And if you look at the picture, that looks about right. Similarly, if we went down root 96, then the y values decrease by root 96. So that's -2 for the y value minus a root 96. And remember, the x's are all 5. So this one would be -2 minus root 96. Or if you did a decimal instead, this one would be -11.798. And if you look at the picture, yeah, it's pretty close to -12 right there. Okay. Let's take a look at number 6. So we got a circular park 80 meters in diameter. So diameter equals 80, which also means that the radius is going to be 40 meters. Has a straight walkway cutting across it. So here's the walkway, that chord right there. At its closest approach, the walkway is 24 meters from the center of the park. So if I draw the shortest possible line to the, or segment to the chord, that's going to be 24. So the question is, let me make that 24 a little bit better. So the question is, how long is the walkway? Let's draw in some radii. So there's one, and we know that that's 40. Here's another, we know that's 40. And so if I solve for this length and then double it, I've got my walkway. So that'd be 24 squared plus x squared equals 40 squared. Let's see, that if we do 40 squared minus 24 squared, then you end up with 1024. And if you take the square root of 1024, you end up with a nice number, 32. And then if we double it, 2x, 2 times 32, 64. So the walkway is 64 meters long. All right, let's take a look at 7. So in 7, let's see, we got 2 congruent chords, and we've got this 84 degree. Sorry, had to pause it for a second. So we got the 2 congruent chords, the 84 degree arc. I don't know why these printed off funny, but these should be moved over. So anyway. Okay, so let's see, measurement of angle A. Well, A is inscribed and it opens right up to the 84. So remember, this was like the 2x if this is x. So just cut it in half and you get 42 degrees here. So A is 42 degrees. ABC, angle ABC. So we got to draw that one in. So A to B to C. Well, they're congruent chords. So in this triangle, we've got an isosceles triangle. So these angles are going to be the same. So if I do 180 minus 42, that'll be 138. And then if I divide 138 in half, we end up with 69. So both of these angles here are 69. Okay. Arc AB is this one. And notice that this angle 69 degrees opens right up to that arc. And it's inscribed because the corner's on the circle. So I'm just going to double it and get 138 degrees for the arc. And then AC is over here, and you can do the same exact thing with the other 69, or you can remember that property that says if you have congruent chords in a circle, right? Whoops, this chord is congruent to this chord, right? Well, congruent chords have congruent arcs. So if this one's 138, this one's 138. All right. Hope that helps a little bit, and I'll see you guys soon.